G'day everyone, welcome back to my channel. A few of you have been asking about my electrical system because, as you know, recently I took the bus up to Airlie Beach to see my electrician to get the solar panels and the big components of my electrical system installed. And a few of you have been asking to see what I actually have set up for my electrical system, and I'm going to be doing a whole video on that very soon. But I realized that I never got around to showing how I did the pre-wiring for all the 12-volt stuff in the bus. I actually ran all the cables months ago and took some footage at the time, but just never got around to editing it and making a video out of it. So in this video I'm going to show you how I did the pre-wiring for the 12-volt side of my electrical system. So I'm going to talk a little bit about what I used and how I ran all of the cables for the 12-volt side of my electrical setup. Now, I do also have a video showing how I ran the cabling for the 240 volt mains power side of things. If you haven't seen that video, I'll put a link to it up here so you can go and check it out, because in that video I also talked about some of the things that you have to consider when you're running both 240 volt and 12 volt wiring together. There are a few things that you need to be aware of. So if you haven't seen that video, go and check that out. But today I'm going to show you how I did the 12 volt wiring. Okay, so there's a few things that you need to consider when you're running the wires for the 12 volt stuff in your bus. And the first one is the sort of wire that you're going to be using. Whatever you do, don't use ordinary house cable for the wiring in your bus or your van. The reason for that is that most of the wiring that's used in houses is what we call solid core. So the wire that's inside the PVC sheath is just one single solid strand of copper wire. And it's not designed to flex or be able to withstand movement at all. It's just designed to work in a stationary building. So the problem with using that kind of wire in a bus is that when the vehicle is moving along the road, obviously there's a lot of little bumps, there's a lot of vibration that happens, and that wire, well, there's a lot of movement that can occur, and that wire can flex. Now, if that wire is flexing over time, it will eventually become hard and can snap. And then obviously the wire's snapped, you've disrupted the circuit, you're not going to get any power conducted through that wire at all. So what you want to do is make sure that you're using flexible multi-strand wire that's specifically designed to withstand the vibration that occurs in moving vehicles. So this here is the wire that I'm using for all of the 12 volt side of my electrical system. And as you can see, it's very flexible. This is actually TiCab marine grade cable, so it's very high quality, and it's designed specifically to be used in boats and other RVs. So it's much better able to withstand the vibration and the conditions that you get in a moving vehicle compared to ordinary house wire. So there's a few things to note with this cable. So first of all, it's what we call twin sheath, which means that it's got two layers of insulating sheath around the wire. So the positive and the negative wires are running together in a single cable, and they are both enclosed in this outer PVC sheath. And then inside that, each of the positive and negative wires again has its own individual sheath. So there's two layers of insulation here which help to protect the wire. Again, you get, like with all the vibration, this wire is going to be subjected, you know, over time it's going to be rubbing up against your furniture or the walls of the cavities in the walls of your bus, depending on where you run it. And so having the two layers of insulation just gives that little bit extra level of protection in the moving vehicle. The other thing to note is that you can see each of these wires is made up of lots of little tiny fibers. So instead of being one single solid core like a house cable would be, these wires are made up of multiple little tiny strands of wire. So, and they're very flexible. So firstly, they're more able to withstand the flexing and the vibrations that they're going to be subjected to. But also, if something was to happen and you did get breakage of one or two of these little fibers, then you've still got, you know, all of these extra fibers that will still be intact, and you'll still get electricity being conducted through. So that's why it's important to use a multi-strand wire in your bus conversion. The other thing to note about this particular cable that I'm using is that the wire is actually tinned copper. So you'll see if you're shopping online for different sorts of wire, some will just be ordinary copper wire, some will mention that they are made from tinned copper. And the advantage of using tinned copper is that it just provides a little bit more protection against corrosion, and especially in something like an RV where it will be sometimes exposed to condensation or moisture in the air. Having the tinned copper wire just gives you that little bit extra protection against corrosion over time. So that's just some things to be aware of when you're considering the type of cable that you're going to be using for your bus conversion. The other big important factor that you need to consider and make sure you're getting right is that you're using the correct size of wire. And this is super important. First of all, you want to make sure that the wire is big enough to handle whatever current needs to pass through it in order to run your device. And it needs to be able to do that without any risk of overheating, because what happens is if your wire is too small to handle the current that's passing through it, it can overheat, and worst case scenario, it can actually catch fire, and that's definitely not something that you want in your bus. So you have to make sure that the wire is big enough to handle the current that it needs to carry without any risk of overheating at all. And the second reason why you need to use the correct size of wire is that you need to make sure that wire is big enough to carry the amount of current you need it to without any significant voltage drop. Now, what do I mean by that? Basically, when you've got current passing through a wire, it's going to encounter some degree of resistance in that wire, which is going to limit the amount of electricity that will actually reach the end of that wire. And the amount of resistance depends on a few factors. Depends on the diameter of the wires that are conducting the electricity. So the smaller the diameter, the greater the resistance. So if you're passing the same amount of current through a big wire and a small wire, it's going to much more easily pass through the large wire than it is through the small wire, because it's going to encounter a lot more resistance in the smaller diameter wire. The other thing that you need to bear in mind is that resistance increases over the length of the wire. So the further the electricity has to travel, the greater the resistance it's going to encounter by the time it gets to the end of that wire. Now, why do we care about this? The reason is because obviously these wires are supplying electricity to some sort of device. So it could just be a light, it could be a USB charging port, it could be something like a fridge or a fan, and each of those devices needs a certain amount of power in order to work. It will need a certain amount of voltage in order to work properly. So what happens is the voltage that is leaving your battery and entering that wire is not going to be the same as the voltage that reaches the end, because you do get a little bit of voltage drop as that electricity passes through the wire. It encounters resistance, and the longer the wire, the more that voltage is just going to drop. Now, if you've got something like a simple LED light that's connected very close to your battery, then the amount of voltage drop that's going to occur between the battery and that light is pretty small, and it's unlikely to affect the functioning of that light. But if you've got something that requires a lot greater power draw, say a fridge, for example, and it's positioned, you've got your batteries at one end of the bus and the fridge is up the other end of the bus, there may be quite a few meters of wire that electricity has to travel along to get from your battery to your fridge. And if the wire is too small and it's traveling over a great distance, then that voltage drop can be significant, and it may end up meaning that there's not enough voltage at the end of that wire to run your fridge. So the greater the power draw of an appliance and the further it is away from the battery, the bigger the impact of voltage drop that can be an issue. So it is something that you need to consider. Now, the easiest way to work out what size of wire you need for each particular appliance that you want to power is to use a wire size calculator or a wire size chart. And there are lots of these available online. If you just Google wire size calculator or cable size calculator, you'll see a bunch of different options. And so what you need to do is, first of all, you need to know how many amps each of your appliances needs to run. So you do this by looking at there should be a label on the appliance itself, or it'll be in the instruction manual for that particular device. But you need to know the amps required to run your device. So for something like an LED light, it may only be 1 amp, or something like that. The little Sirocco fans have a very low power draw and use only about 0.5 amp. Something like a 12-volt water pump may use 5 amps, so a little bit more. So you just need to make sure that for each of the devices that you're wanting to connect, that you work out how many amps that device needs to run. So that's the first thing you need to know. The second thing you need to know is how long is your circuit between the battery and the device that you're powering. Now, you just need to be careful with this and make sure that you're using the correct value for the particular calculator that you're using. Because what you need to keep in mind is that the length of the circuit is the total length that the electricity has to travel along. So that means it's going from the battery along the positive cable up to the light or whatever device that you're powering, and then from there it travels back to the battery through the negative cable. So the length of the circuit is actually that entire length, including the positive and the negative cable. Now, some calculators do their calculations based on the length being that total return length. So when you're plugging in the length of the circuit, you can't just measure the distance from your battery to your light, because the actual length of the circuit is twice that distance, remember, because it's got to turn around and go back to the battery. But some of the calculators actually kind of adapt for that and have their calculations adjusted so that the length you put in is actually just the one-way distance. So you just need to make sure that you're plugging in the right distance, and it should say on the calculator or the chart that you're using what it's actually taking to mean the length of the circuit. This particular one that I use, the Blue Sea Circuit Wizard, uses the length of the circuit as the total return distance. So if I've got a light, for instance, that's 6 foot from the battery, then the length of the circuit is actually 12 feet because it's got to go out and back to the battery. So it's just something that you need to keep in mind with that. So once you know the amps required and the total length of the circuit that's involved, you plug these into the calculator and it will give you the correct wire size that you need. So this is the calculator that I used. It's an easy one, it's online, it's totally free. And I'll put a link to it in the description below so you can check it out for yourself. But we'll use the example of my water pump to show you how it works. So you enter the circuit voltage, which in this case is 12 volts. The number of amps required on the load in the case of the water pump is 5 amps. And then the length of the conductor. Now it actually tells you here that it's taking the total length as the return length of the circuit. So both the positive and the negative cables are taken into account. So in my case, the water pump is about 6 meters from the battery. So the total length of the circuit then is 12 meters, which is about 39 feet. So I put 39 feet in here and then hit calculate. And it tells me that I'm going to need 12 gauge wire to connect up my water pump. Now, just as another example, we'll go back and change the entries to do a different calculation. If we were saying, instead of hooking up the water pump, I was hooking up a couple of LED lights that are only going to use 1 amp. So we'll keep the circuit length the same. And if I calculate this one now, it tells me that for a couple of LED lights at this distance, I would only need 18 gauge wire. So you need to go through each of the devices that you're wanting to connect and do that calculation for each of them to work out what size wire to use for each of those things. It's always better to err on the side of getting slightly bigger wire than what you actually need, rather than risk getting something that's too small. The only real risk to using bigger wire is that it's going to cost you a little bit more to buy. So for my setup, I just decided to connect everything with the same 12 gauge wire, because I had some things like my water pump, the max air fan that's at the opposite end of the bus to where the batteries are. Those things were going to require 12 gauge wire, and I had a bunch of other things like LED lights and the Sirocco fans and things that only needed 16 gauge wire. But I ended up deciding to do all of them with the 12 gauge wire simply because it worked out cheaper to buy one size wire in bulk rather than smaller quantities of all the different size wires. So it means everything in my bus is going to be wired up with the 12 gauge wire. So that will be sufficient for the larger draw, power draw, things like the max air fan and the water pump. It's going to be way more than I need for the lights and the fans and the other smaller devices, but it means that there's going to be virtually no risk of voltage drop, no risk of that wire overheating, because in most situations in my bus it's going to be carrying way less current than it's actually designed to withstand. So it's a lot safer all round. Right, so I think I've got everything here that I need. So I've got some conduit here. This is actually fully enclosed corrugated conduit. So this stuff's 32 mil. I've also got some slightly smaller 20 mil that I'll use for a couple of things. And I've also got some of this split loom tube. This stuff is 13 millimeter diameter. And this here is my 12 gauge wire that I'll be using for all the 12 volt stuff. I've got some electrical tape here. I've got some strong scissors that I can use to cut the conduit, and I've also got some side cutters for cutting my wire. And I've got a marking pen here because my plan is that I'm going to be labeling each of the wires so that I know which appliance they're for. So that's why I've got the white electrical tape and a marker here to make sure I'm labeling all the wire correctly. Alright, so I've got my list here of all of the things that are going to be connected to the 12 volt system in the bus. Hopefully I haven't forgotten anything. So on the driver's side I'm going to have a toilet fan, so that's the exhaust fan on my Nature's Head composting toilet. There'll be a water pump, and also connected into that same water pump circuit there'll be an inline water gauge which will tell me how much water I've taken out of my tanks. I'm going to have a light above the kitchen sink that will have its own dimmer switch, and I'm also going to have a light above the bed which again will also have a dimmer switch. There will be a USB charging port on the driver's side as well, but it's actually going to be part of the circuit coming from the passenger side. I also have a camera monitor that will be sitting up the front on the dash, but will actually be run off the house batteries, and it can run on 12 or 24 volt. I'm probably going to run it off the 24 volt in my system just because that's what the batteries and the base system in the bus is, but I'll still be running it with these wires just to make sure that I've got enough wire in the space for that. And then on the passenger side I've got a couple of LED lights that I will actually have connected as one light with a switch. So that will be the light over the kitchen bench and the table in that area. I've got a couple of USB charging ports. One is on the passenger side, the other one is on the driver's side, but I will run them off the same circuit. I'll have a little Sirocco fan, and I've also got my two max air fans. The wires for those will be running up this side of the bus as well. And I'm also thinking I'm going to want some sort of light in the entry stairwell area. I haven't quite decided what I'm doing for that yet, but I'm going to run a wire up to there anyway so that that's in place if I decide to do something with that. And then in addition to all of the things on the driver and passenger side, I'm also going to have a bathroom light at the very back of the bus. So they are all the things that I'm going to be installing that all need wires run to them. So that's what I'm going to be doing today. So I'm going to start with the wires on the passenger side of the bus because that should be fairly straightforward. Most of them are going to be running in the inside of these upper cabinets. You can see I've cut holes in the dividers at the top, so most of the cables will be running along here and they'll come out into this wall here that I've got in the entry stairwell, and there'll be a couple that'll be going across here to this side of the cab as well. That should be fairly straightforward. I can just run them through those cabinets. Alright, so there's my conduit running along the inside of the cabinets here. And you can see I've got it secured in place with cable ties. Actually put these little screw eyes on the inside there so that I could have something to attach a cable tie to. There you can see the cable tie going through the screw eye there. When you're standing back from the cabinet, you can't even see the conduit behind this. So I'm happy with that. So now I've got to thread my wires through here. I tried threading the wires through the conduit individually, and although I managed to get the first two through okay, it was just impossible to get any more than that through. Now the problem with the conduit is that it's corrugated on the inside as well, so the wires kept getting stuck on the corrugations, and any little curve in the conduit just made it so hard to get the wires through this way. Alright, so I've got my 4 cables here. I've taped them all together at the end, and this will hopefully make it a bit easier to push it through the conduit. We'll see. Okay, so there's my conduit coming out from the overhead cabinets here into the electrical bay. So there's my 4 wires. I've got one for the max fan at the front. I've got one for a little Sirocco fan if I put that up the front. I've got one for the entry light, and I've got one for my USB ports that are going up the front. So they're all there, and you can see I've got this extra little one here. This is for the light that's going to be going over my kitchen bench and the table on the passenger side. It's going through the pantry up here as well. I've put that in a little bit of conduit as well. I mean, it's a fair distance from the 240 volt cable here, but just as an extra precaution, I've run it in some 20mm conduit there, and it will come out into this overhead cabinet. There's going to be a front on this which will have the dimmer switch for the light, and these wires will run through the floor here to this light that's going to be running under the cabinet here. So that's that little one there. So I think I've now got all of the wires run for the 12 volt stuff on the passenger side. Now I need to do the wires for the things on the driver's side. And this is a little bit trickier because these wires have to go across the bus and down into that space. So it's just a little bit more awkward for maneuvering the conduit and so on. All right, bus is starting to look like a bit of a disaster zone today. I've just shifted my fridge out of its position here so that I can see the space that I've got in the back here where the cables need to run across. That's my 240 volt cable down there on the floor that I ran the other day. I need to obviously tidy that up and secure that along its path there to that power point. So I can do that now that the fridge is out. And this here is the conduit that will have the 12 volt wires that are coming across here. So it's running under the vanity here, up through this corner, all the way along and back to here in the electrical bay. Now, I don't think I'm going to be able to run the wires with the conduit in place because there's just too many sort of curves that I think are going to be very hard to get the wires through there. I mean, it was hard enough on the passenger side, and that was a relatively straight line. So what I'm thinking is I'm going to take this conduit out and do it, like lay it out flat to thread the wires through, and then hopefully I'll be able to come back and thread the whole lot together. Alright, so here are all the 12 volt wires that are running across to the driver's side. So I'll just show you what I've got here because I've got a few different things of conduit. In this large conduit here, I've got these 3 wires running. So there's one that goes to my water pump, one that goes to the light above the kitchen sink, and another one that goes to a light above the bed. And they're all running in this main conduit here that runs all the way across, down, under the vanity, and you can see it comes out there. And once it gets to there, it's going to be physically separated from the 240 volt via this wall paneling here. So I can run the rest of it in split loom tube. So I've got the 3 cables running across here. This one's going down into under the sink cabinet for the water pump, and the 2 lights are running up the wall here, and the one for the sink, which is just going here, comes out through a hole in the cabinet here, because the dimmer switch will be on the front of the cabinet here, and the light will be underneath this cabinet. And then the one for the bed light is coming out this hole here, and it will run inside the floor of the cabinet all the way up to the bed. You can see it coming out the end there. Now, also running on this passenger side, I've got this shorter wire here that's going to be for a bathroom vanity light up here, and it's running in a separate piece of conduit along to here. I think it's actually this one, comes out here, bathroom, and then the other one I've got here is for the toilet fan, and it again runs in the solid conduit all the way along here, down that corner, and it comes out here, and then I've got plenty of wire hopefully left over to reach down to the toilet fan. So that was a job and a half to get all those wires in. I hope I've got enough left on the ends of them to be able to do all my connections here, because I'm now officially out of 12 gauge wire. But yeah, so those wires there are all my 12 volt things. I decided in the end to run the camera monitor on the passenger side, because it was just so hard to feed wires through this longer piece of conduit. I just gave up in the end, and I'm running out of space up here. So I actually decided to run it up the passenger side and into the front cab. So that's this one here. I've actually got it running in the same bit of conduit that that the light on that side's running in, so I didn't have to cut any more holes in my cabinet. But yeah, so it's spaghetti central here now, but I think all of the cables that I'm going to need are run. When I get back home from the trip to the electrician, I can hook all this up to the 12 volt stuff.